Welcome back, everybody. Well, this is step 2 of the EFI conversion. Some people might be thinking it's step 2 of heresy. Oh well. Sorry. Wrong channel. What it is that our step 1, the crankshaft positioning sensor and toothed wheel. So we understand where the crankshaft will be. Step 2, how do we get the air in there and to regulate the amount of air going in there? Well, we need a throttle position sensor to tell the ECU what it's doing. Well, step 2 will be the intake manifold and throttle assembly. I am not going to hurt any of this stuff. It's all going in a box. I'm going to be building our own, but there's a reason I'm building it, or a certain way I'm building it. Now, the first thing is, I'm going to bring you over here. I'm going to show you what this is, how they did it, and the routing. It's fascinating. They did a wonderful job. These guys, leave it to the French to expand the boundaries and think in a different way, which that's the reason why I really like French cars. The way they did it was very, very interesting, you know. And you have to remember, they did a lot. They were doing a lot with turbochargers in Formula One, and they were making some pretty nasty wow in some of those. But let me move the camera over. Let me show you. I'm going to pull this stuff off that I was using to save, you know, some stuff going down inside there. And let me show you the whole system and what they did. And then we're going to pull it off, and I'm going to show you what I use for the new system. Here is the intake system on the R5 Turbo. It's actually quite fascinating. What it is, we have the throttle body right here. You have a butterfly acting just like a carburetor. And what it is, it opens up, allows air into the turbocharger, pressurizes the system, gives you a boost. There we go. Everybody's happy. This right here is the intake manifold. All it is just cast pipes with an integrated chamber in between all 4 pipes to allow for an idle circuit and a cold start circuit. You're probably wondering, why is it cold start? Because we have right here, which is not on it, is a cold start valve. Right here is the idle circuit. The idle circuit is controlled by this. This is like an idle screw in a carburetor. That's all it is. Now, when it's cold, this right here is a warmer regulator, which allows more air into the idle circuit. So when it warms up, this closes up. The idle circuit is controlled by this. I mean, there is a little bit of bleed through on these, but it's mainly controlled with this. That way it's all set up. Now, what we have here is, right there is like your PCV setup. Right here is their control pressure regulator, which is still on the entire injection system upstairs. This side right here is a vacuum. This side right here is just basically a dump pipe. That's all it is. You know, that dumps it back into the throttle body. This pretty much is when it's under vacuum, and when you snap it, it lowers the pressure, gives a little bit of, it's like an accelerator pump in a carburetor. You know, because it just gives, you can watch the gauge, and when you rev it, you can see the gauge go down like this, you know. And it's actually pretty cool when they actually work really well. That way, you know, it's like an accelerator pump, pretty much just squirting fuel in, because the less pressure that you have on the actual top of the fuel distributor, the richer the mixture. So when you push it, it automatically goes rich, then it kind of balances out, and then you go. Which is, I think it's actually a great system for the 70s. We're not in the 70s. I hate bell bottoms. So, what we're going to do now, let's pull this off, and pull all these pipes off, and let's clean it up, and let me show you what I got to actually make our new intake system. Here's the system. As you can see, that's where the injectors go. That is for the cold start injector. Here's the idle circuit. Here's all the lines. And there is the throttle body. And you can see these 2 lines right here are before the throttle butterfly, and 1, 2, 3, 4, 5 lines are after. So this is the vacuum section. This is the non-vacuum section. Just thought I'd show it to you. And I'll put this all away. Thank God. Here's the old manifold. I took off the vacuum lines basically, you know, on the idle control valve. What it is it's just a straight through manifold cast. Pretty much nothing, you know, pretty easy. But I don't want to harm that. And what am I going to use for my throttle body and for, you know, the inlet manifold into the car, into the engine? Well, it's this. It's a set of bike throttle bodies. And this is probably the most spirit of the engine is the way it is, because you have to remember over here was the butterfly for the turbo. So when this thing was open, there was no restriction from here, from the turbo through the intercooler into the motor. I'm just doing it in a different position. What I'm doing is, like, when these throttle bodies are open, there's no restriction from here all the way through to the cylinder head. And that's kind of what, yeah, I mean, let me run with it. that's what I'm trying to do. But what does this do for me? Well, it does a lot of things, you know, and it's simple. I don't know if it simplifies or complicates things, but in my mind, it kind of simplifies a lot of the work that I have to do. First thing is, what does this have? Well, it has the butterflies right here, but it also has the throttle position sensor for the ECU. That's a pretty big thing. You got to make sure you have that. Then we have all the injectors right here, and we have a fuel rail with, which I really like. These are, you know, factory style connections, and you can make your own hose. And this, I like these because they really work well. Okay, there we go. We have the fuel rail, and we also have a port right here that's been capped off. We can use this for our fuel pressure regulator if we want. I'm not really sure if we're going to do it here or at the filter, because we can always use the BMW filter that recirculates, and just, you know, have the have the pressure set up through there. That's what I've seen. I'm not sure. I'm probably going to have an external regulator because I think it works better myself. Okay. Also, what we also have is vacuum ports here, 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 and here. What does that do for us? Well, we can have an idle bypass valve using these ports. I'm really skeptical on whether or not they're going to be big enough to actually do it, that we can, you know, channel into a standard idle control valve or whatever, and then make it work. I don't know, but I'm going to try. I mean, I think, seeing how I already have the ports, I mean, it's a lot of things already done. And plus, seeing how we're using, you know, this engine right here used a throttle cable, we have a throttle cable, right? I mean, a throttle actuator right here. And if I'm going to take this off, but this just gives you a higher idle if we wanted it. But, you know, that's the whole thing, is we have this available to us, and we can set, you know, the position of the throttle, and I mean, there's a whole host of things that we have with this set of throttle bodies. I mean, it's all a self-contained unit. There's a lot of fabrication work done with just doing this. You know, a lot of fabrication work. Now, let me show you where I'm going to put it, or how I'm going to set it up on the engine. I'm going to go get the intercooler, bring it back and show you, and I'm going to put the original manifold back on and show you what our problems are going to be, or our somewhat solutions are going to be. All right, let me go grab the intercooler. I'm going to change the camera angle and I'll show you what it is. Here's the intercooler. Here's where the intake is. I know this thing looks pretty odd because this is, you know, it's not a very big intercooler. It's pretty decent, you know. What it is most people have one pipe in, one pipe out. Well, the French had one pipe in and 4 pipes out, you know, but it works pretty well, and it's set right up and pretty good. We're trying to, you know, we're trying to mimic this. Let's pull this off. And what we want to do is that we have the throttle bodies right here. And most people, when they put throttle bodies on a car, they sit there and go, okay, good, I need to get at the injectors. It's going to have to sit right here. And it's like, oh, man, I got to move the distributor. No, I can't move the distributor, because the thing is, I'm going to start this motor on the distributor, and we're only going to do fueling basically at first, and then we're going to progress it to make everything run reliably. And if I go on coil on plug or wasted spark, I'll do that, but I'm not really sure yet. I mean, if this runs good, this is gonna be running good. That's all that matters. So what am I looking at? Well, in order to turn the distributor, there's no way I can do it. Say, how can I move the injectors? Can I do this? And I said, you know what? I gotta think of the French way to do things. I'm gonna turn it upside down. And I turned it upside down going, huh, that looks awesome. And I got tons of room to move the distributor. Great. All right. Now, you're probably saying, well, geez, you know, you sit there and you have your butterfly switch right here, you know, to do the throttle butterflies. And you say, oh man, you're not going to be able to bring the cable that was operating this over to there because you don't have long enough. Well, that's it. If you have a front engine rear wheel drive car or front engine front wheel drive car, yes, absolutely. I wouldn't have enough throttle cable. But you have to remember, this is mid-engine. The front is that way. So what am I doing with the cable? I'm moving it over here, so I have a lengthened amount of cable. So it's a win-win. I'm looking at it going, oh, great. I can run the cable wherever I want because I'm going to have plenty of excess cable. Also, when you have the injectors underneath here, we have down there on the front crank, the crank position sensor. Then we also have the oil pressure unit and the oil light. And we also have this right here. This is the plug for the distributor, for the electronic distributor, which goes down here. It went right by the dipstick, right down here. And if we have the injectors all down here, all the wiring is self-contained right there. And I'm looking at it going, you know, that's a lot of benefit because we're using less wires or less amount of wire. And theoretically it's lighter, but it's not. But it is, but it's negligible. But we have everything pretty much self-contained down here. If we have it up like this, we can use a straight coupler right into the intercooler and it's gonna work great. At least that's what I think it's gonna be. Now, also, we also have to figure out a couple other small things with this, but when we get to that, we'll get to that. First things first, let me I'll show you the stuff that I'm gonna use for the intake manifold, or what I'm going to make the intake manifold out of. This is what I have to make all the flanges for the manifold. What it is, it's 1/2-inch aluminum. It's pretty much, that's all it is. My friend owns a machine shop. I went down there and grabbed some. I mean, if you have machine shops in your area, I'm going to tell you right now, if you went down there and showed them, hey, I'm building a race car and I need, you know, 6 inches of 1/2-inch aluminum, would you happen to have something you can sell me? You know, and if you bring in like, you know, this manifold saying you're trying to do something like that, they'll generally give you the stuff. But the whole thing is, remember, you're going to have to bring them back like a box of donuts or a coffee cake or something just to say thank you, you know, because they helped you out. You should, you know, return the good nature, you know. So what are we going to do? And why do I have to get a 1/2-inch plate? Because, you know, the flanges aren't 1/2-inch. Well, what he had was generally, you know, on standard stuff is like 3/8 plate, 1/2-inch plate. That's what they have, you know. And looking at this manifold, they're about, this is 11, 12 millimeters. It's roughly that. And why am I, you know, why didn't I just use 3/8-inch plate? Because of this. This is the alternator mount. The alternator mount, this bolt right here bolts to this, you know, or holds this part of the intake manifold in and bolts to the head. So if I have a 3/8-inch plate, I'm going to have to actually build it up with weld or and then mill it down, or I use a 1/2-inch plate and just mill it down, you know, and then I can get an exact distance of where this is supposed to be. It'll fit right in. We'll be good to go. What I have to do now is I have to just basically copy where all the flange, you know, where the flange is, and just drill the holes, the 8mm holes. And then I'm not going to drill the center holes yet. I want to get the 4 flanges done, set up, put on the car, and then we're going to continue there with the piping that I also got from him. I'm a bunch of freaking donuts. All right, let me just get to work on this. I'll get my stuff on and we'll start cutting the stuff up. Here are the 4 pieces for the manifold. What we have to do now, I left them all a little big. The line is on the, where you should cut is right to the line on the inside, but I cut it up to the little bit of line on the outside. Let's see if we can get these to fit on the cylinder head, and then we can figure out how we can make the transition from this to the throttle bodies. I have the flanges bolted onto the head, pretty much trimmed around. I had to do a little bit of trimming here to make sure they all fit, but you know, they're pretty much lined right up and went right in. I did not drill any holes to indicate where the ports are because I don't want that just yet. The first thing we have to do is we have to figure out where or how we're going to make these throttle bodies go into the intercooler, and they have to be at a certain angle. How are we going to do that? What I have now is this is the original setup, you know, for the intake manifold. What we have to do is measure this angle right here. Now, let me bring you down here and let me show you how I'm going to do that. Well, there's our angles. We have to do, this is our intake manifold. And to go back to the beginning is, we made the flanges as an adapter for the new intake manifold to adapt to the cylinder head. Here is the runners, or the angle runners, to give it to the correct pitch on where this thing's going to go. Now we got to make the adapters from the angle to the throttle bodies. How are we going to do that? Well, I got this. Went down to my friend's shop, picked through his pile, and we found this heavy, thick wall 2-inch tubing. What is it? This tubing is larger in diameter than this. What do I want to do? I want to cut this, or bore this thing out, and create a shoulder on the inside, so when this thing goes on, this thing will go on probably about 5 millimeters, 6 millimeters, and basically rest on that shoulder that's inside this pipe. Now, you're probably saying, why do you want it to rest on the pipe? Because what I'm going to use for a gasket to adapt this to this is going to be an O-ring. And I look down the road. When you look down the road, you're sitting there going, okay, well, I need to get parts for this. So if I'm going to all the trouble to make something adapt, I want to get the least expensive parts that I can to make it work, and the best parts I can seal it. And you have to remember, little O-rings on hydraulic cylinders keep back 3,000 to 4,000 psi. That's what they do. And you can't get a better sealing than if the O-ring is cut correctly and crushed and is actually really sealed to this, you're not going to blow it with just boost pressure. 18 psi is not going to blow that nitrile seal. So the big thing is I got to figure out how much depth. I got to look on the manual. I got to figure out how much depth I have to cut to make a groove to allow that 2 millimeter O-ring seal to compress, but not compress out. We need to seal, but not to break. That's going to be the big thing. But the first thing we have to do is cut 4-inch, 1.5-inch sections so I can put it in the lathe, clean them out, and then I can set this in where the shoulder meets this at the correct depth. And then I'm going to cut the groove for this, or for the O-ring, to go in there, compress, and seal. Also, down the road, to get an O-ring for this thing, just like, if they got hard and they cracked or whatever, just through heat cycles, I got a bag of them of 20 for like $5.60 off of Amazon. I mean, I think I'm going to be good for a while. But, all right, let me cut 4 sections of this about 1.5 inches apart, and I'm going to put it in the lathe, and we're going to cut this thing up and make a shoulder to make these things work. How's that for tight? There's our 4 things, our 4 pipes. Let's see, we can adapt them to that manifold. I think that looks pretty cool. What do we have now? We have the ITP cups, sort of like an injector cup. We have them right in there, and they fit, well, know, pretty nice, you know. No obstructions, go like this. Also, I got in the mail my O-rings off of Amazon for $6 for 20 of them, or is 5 something for 20 of them. So I decided, okay, well, here's the O-ring. I'm going to put it in here, and oh, it fits just perfect. I mean, it fits beautifully. And then I put it in here and going, all right, well, if I push down to make a seal, it has a lot of resistance, so you know it's sealing all the way around the perimeter. But here, let me take these off. There's a problem. You see right in here, that seal is protruding out. I need to stop that. Why is that? And it's not because of boost. Boost is pushing against the wall of this bung, if you want to call it that, or the ITB cup. What I need to worry about is the vacuum that's created when you close that throttle body and the air is being sucked into the motor. There's a good chance this O-ring will suck right out. What do I have to do? Well, I'm sitting there going, all right, well, what do I have? Looking around, trying to figure out how I am going to make this thing work and still have, you know, do I have anything that'll work? So I looked around, I found this. This is aluminum pipe for water tubing. You know, for doing a mid-engine car, you have a water pipe that goes back and forth, and basically it's it's like 1.5-inch tubing or whatever, or something like that. But what it is, I put it in there and say, oh, isn't that interesting? You know, and I look in here and go, okay, well, it's a little small, but I think I can make something. Then I started walking around going, of course I'm a hillbilly pack rat and people give me things. Just like, hey, you want this? I got some aluminum tubing. Well, a friend of mine gave me some aluminum tubing, and I sat there and, well, here's the aluminum tubing. It's a jack handle. It's just like, oh, okay. But if you take a look at it, take a look at the actual width inside here. It's actually really, really thick. And I put this in here going, all right, well, geez, that would make an awesome seal. It would give me plenty of meat that I can basically grind out and port to make it, the correct diameter. And what also I did is I grabbed just a piece of aluminum, just a piece of junk aluminum. I just put cut it off to make, it's sort of like it looks like a cam bearing, and just put it inside. Only thing this does, right there, and right there. See how it works? It centers everything in the actual, it's basically, it just centers it, is what it does. And if you put it on here, onto the ITB, and you just force it down, it's not going anywhere. And if you look at it, it's not going to be forced out because it's completely sealed on the inside. And there's not enough force. Let's say the vacuum curves around it. There's not enough because this actual ITB is actually holding it inside. So I think that's a win-win. Plus, I'm going to use this for the tubing to go to the cylinder head because I found another thing that's a problem. So now that we have the gasket set up for the beginning portion, we have the gasket set up for the ending portion, we have the mount set up for the beginning, and the mount set up for the ending, we got to connect the two. Well, this is going to be the problem. Here, let me move this. Put these back on. And if you look, let me show you how I'm going to set this thing up. Because the first thing is we have to first get the measurements to make sure it looks, or as you actually set up in the original and correct position. Here, let me bring you over here and give you a closer look up of what's going on. Here's the original intake manifold for the R5. What do I have it? I have it sitting on here on the bolts or the studs that are coming out. What is it? They're about 21 millimeters out, 13/16 of an inch in Yank speak. Also, I marked on here with a piece of tape and a pencil the angle of what this is. Remember, I believe we measured out at like 37 degrees. We need to get those ITBs to this position, but further in by 21 millimeters or 13/16 of an inch. So what do? Well, first thing is, seeing how we're experimenting, I'm going to take this and not drop all of the caps. Like that. There we go. It's like, but if I have that like this, take the ruler. That is the angle right there. So we are still out about 13/16 of an inch right there. What I have to do is I have to shorten those ITB caps is what I have to do. So what I'm going to do is I'm going to bring them onto the lathe. At first I'm just going to cut them in half, and if I need to bring them down more, I need to bring them down more. Then after I get those cut, I'm going to take these off, mark it with the gaskets where exactly the intake ports are, and then we're going to try and build our roadmap from the ITBs to the cylinder head and make it work. That's my philosophy, or my plan. Whether or not it's going to work is another thing, but hey, you know what? Let's just give it a shot. Whew. All right, let me go over to the lathe. I'll trim those up, and then I am going to take these off and mark exactly where the intake ports are. What I'm doing is basically I have the depth of this shoulder right here, and I'm basically doubling it all the way down. So it'll give me a room to actually, how can I put this, trim it if I need it. And what's the measurement? It looks like it's 18 millimeters from the edge to where I'm going to cut with a parting line. Also, don't forget, you have to use I use a screwdriver. I go down, I find where the dog is, or where this holder is, and I go like this. Yep, it's going to clear the cutting tool. So that's a big thing. You don't want the cutting tool to hit your lathe chuck. But okay, I just thought I'd let you know what I'm doing and what the depth of it is. And now I'm going to cut it because I have it all set up for a parting line right here, exactly where it is, using this, because I'm using this side metal on aluminum. This thing gave me a really good mark right here. So when I start the lathe, I can just bring it exactly where it is and part it. And I'm going to use the same measurement for every single one to try and keep these exactly the same. At least to give it, some semblance of continuity. All right, let me start this up and let's get this thing going. Here are the cups for the ITB. All nice. Everything is the same. I cut everything to 18 millimeters. That's kind of what I wanted. The next thing I'm going to do is I need to have a manifold or a bar right here in order to do three things. First thing, to keep the spacing correct so the ITBs will just slip on. Second thing, to keep the spacing correct so these things are flat to each other and so the O-ring compresses correctly, that it does not bind or it doesn't seal properly in one place. So it has to be absolutely flat to the ITBs. And the third thing and the last thing is we need a plate right here to connect the ITBs to compress it to this manifold. So it will actually compress the O-ring, seal it, we won't have a problem. All right, what am I going to use? Well, I'm going to use more of that, I think it's a door threshold. I don't really know, but what it is, we use it for the VR sensor. And I'm just going to put it here. I am going to cut it up and pretty much, weld everything around so it doesn't go anywhere. That's my main goal. Let's see if it works. Let me get my stuff on and I'll cut this up and I'll use the hole saw and cut this all up, and I think it's going to work okay because it's so stiff and so thick. And then I'll set the thing up and I'll weld it onto the cup so we have an exact placement of where everything is going to be. So we know the intake manifold and the ITBs will match up. That's a big thing. All right, let me get my stuff on and cut this up. We will get to work continuing on the build. Seeing how this has a stepped lip right here? This is the face right there. So when I drill the hole, this will be cut out. And that's kind of what my deal is. So now we have to set these things to figure out exactly where they're supposed to be. Here's the piece I just used in the drill press with the hole saw. As you can still see, I got tons of flashing around here that I have to clean up with the die grinder. And I'll do that in just a second. Here's the ITBs, here's the throttle body cups. I want to put them all in to see how close I got, because the whole thing is, you know, I mean, I want to keep it kind of loose so when I weld it, use the weld to close up the gaps a little bit. But, you know, when you sit there and you look at it like this, take a look. That's pretty close. That's pretty close. I'm still gonna, I mean, right now, I think this side's a little too tight to this. You know, I want to kind of have these things loose so when I put this bar down on it to set the thing, so I can make sure there's no gaps for the O-ring. I want to expand this out a little bit just in case, and I'm going to get the flap wheel, I'll clean it all up. After I do that, we're going to put this thing on and tack it in and see how it works. But I'm pretty happy with just the initial cleanup or the initial hole punching. I think that's going to look pretty cool. All right, let me get this die grinder harded up. I'm going to get my stuff back on, clean this up. Then I'm going to use the flap wheel to clean everything up for welding it. And that's let's get this step down before we move to the next step. Okay, they all have just enough play to spin around, so I know this is 100% sealed. This is where it's going to be welded. What I have to do next is I have to put my bar right here on this, and seeing how some of these throttle bodies, most of them, 3 of them were good, 1 of them wasn't, so I have just a little hair of play. I'm just going to put some pieces of paper underneath here just to compress it down like a gasket. You know, and then I'm going to weld around it, bring it over here, weld around that, then pull it off and weld it all, and see if it all comes back together again. Whether or not it does, it doesn't. I don't know. So, all right, let me go get the flap wheel, clean this up so I can weld it up. As you saw, I shimmed this one because it's either this or this. Well, they're not equal. They're pretty close. They're really close, but they are not equal. And plus, I probably could have cut one a little bit less than my measurement could be a little bit off with a little bit off on the ITBs. You get more play. So what this is doing, all these shims are doing, it just is no play. And it's absolutely, you know, you cannot push down any more on these because you got a flat sealing surface from the cups to the ITBs. What I got to do now is I got to start welding this up right here, weld this all up. That way it's not going to move. Even if I take this off and weld the other, you know, this other portion up here, it should not move at all. But the first thing is let's weld this stuff right down here, and I think we're going to be good. Here it is. Fits really tight. And I mean tight in a good way. What happened was after I welded this, and one thing you're going to run into when you weld this stuff, I got everything there is pushed all down, no problem. We have, made nice mating surface right down here. That's all well and good. But what happened was it contracted and released, and it basically hung up on the actual throttle bodies. The throttle bodies are cast, and what it is, what I was getting these light witness marks on here. And it's like little jagged marks on the actual throttle bodies that are digging into the side of these ITB cups that I built. Because these aren't machined on a lathe. At least they don't look it. Looks like they're just fully cast. And so what you're going to do is what I did is I took this die grinder with a flap wheel. This is for polishing. It's not for cutting. And what it is I had every single witness mark in here. I just smoothed it down. I kept going back and forth, tapping it down, getting the witness marks, smoothing it up. And then now you can sit there and go, okay, click right on. And we got great mating surfaces all the way around. Let's bring it back over to the engine. We'll continue over there. Take a look right here. You see this little mark right here? This is what's holding up the throttle bodies off of these cups. What it is that when they cast those throttle bodies, there's little ridges. You have to remember, those throttle bodies were designed to have hoses put on them, not to be put into a machine surface. So I am just smoothing this wall down with the flap wheel on the die grinder. Just to let you know that's what I'm doing. I'm not taking much, just enough to stop the resistance, and that's it. Here's our fancy dancy manifold for the ITBs. And this is where it was, and this is pretty much where we're going to have to be. It's going to be a really short manifold, and it's going to have to be tipped up like that. What we have to do next, see these flanges. We have to know exactly where the port is and cut where the port's going to be. How are we going to do that? We're going to take the gasket. We're going to pull this off, take the gasket, wherever which way it's supposed to be, like this or like that, because they're all kind of different. They're all kind of offset. And what I need to do is I'm going to use the hole saw to cut probably 3/4 of the way through it. That'll show me a really good indication where I am going to have the pipe go down to, or the intake runner go down to feed the port. Let me pull this off. We'll mark it. Then we'll drill some holes, and with the hole saw and pilot hole, we'll cover the pilot hole with tape, and then we'll put it back on. That'll give us an exact location of where we want to do it. Let me go get my wrench and we can pull this thing off. Here's the intake flanges for the head. As you saw, I cut this with a hole saw, but I only cut it so far. That's why I set the depth gauge on the drill press. Why is that? Well, I want to make sure I know exactly where the port is when I put the pipe there to weld it. First thing. Second thing is, you just remember, this is set up for the gasket. It's not set up for the actual port. It's for the gasket. We might have to, when we have this thing pulled off, when I pretty much smooth everything out and just match it, I'll probably have to, cut a little bit here and there. But, it's just, is this undersized? Just a hair undersized, but not much. It's almost exact. What the good thing is that when I have this all welded in, I can turn around, pull the tape off, run the hole saw with just a hand drill, and just pop them out in just a couple of seconds. That's the reason why. But we've got the majority of work already cut and already straight, and it should be pretty good. The next thing we have to do is to go from the ITBs to here. Now, the first step, we have to do that in a couple of steps. The first step is we have to be concerned with getting our gasket, our O-rings, to seal. So we need to go cut up that pipe right there, the jack handle pipe, so the O-rings will sit. And we also have to make a spacer so it fits in there really tight, and then I'm going to weld that to that. That way we know the O-ring's all set. I'm also going to cut them in the lathe with an angle, so the air is going to go in there nice and nice. That way when we smooth the rest of it out, we cut the rest of it out with the die grinder, to basically smooth out all the bips and the dumps and stuff like that. That way, just an easier transition, just less stuff to cut off. But other than that, let me get that pipe. Let's start measuring it out, start cutting it up, and then we can make this. Make the seals hold first. Then we will have a place to weld the pipe from here to here, because we've got to figure out the angles on where we're going to go. That's the big thing. And then once it's all pretty much set up, I mean, there's going to be gaps, there's going to be like, but once I am sure that the nuts and bolts are going to be able to be pulled off of this thing, that way I can get it off that way, and then we can make it work really, really well. At least I think, because this is not going to be that bad of an angle, right here. It might work. Who knows? But who else is using an old jack handle for an R5 Turbo? No fucking hillbilly else. I'm the biggest hillbilly out there. All right, let me go cut the jack handle up and put it in the lathe. We'll smooth it all up and make the transitions. There are our caps. What I did, when I first did it, always face the back. I cut the air slot coming in here, just, instead of porting it, I just did it with the lathe. And I put a chamfer on here so the O-ring goes on and it doesn't catch. That's the big thing. Now, what do I have to do? I have to fit these to this, to the manifold. Now, looking at this going, okay, well, what do I need to do? I have to have this thing centered. Because if you don't have it centered, one side could crush the O-ring. I mean, you're just trying to eliminate a lot of the problems if you have something off-centered. You don't want the O-ring to, bind up on one side and not on another. And we're just trying to eliminate that possibility. So what I did is like, okay, well, what did this thing actually turn out to be? And it's exactly 40 millimeters on the external portion diameter. On the internal portion of this, was exactly 44 millimeters. We have to take up 2 millimeters of space all the way around to get the 4 millimeters. This was the panels that we used for the Audi rally car for the dashboard. And I sat there and I put this on going, wow, it is so close to 2 millimeters. This ought to work. And it should, because I've done it and it does work. But I didn't clean it. So what I got to do is I got to use a flap wheel, clean up all the stuff on this, because when I weld it, I don't want it to spurt all over the place. Then I'll turn them all into a circle, like a cam bearing, and put this thing inside, set it all up, then I'm going to tack it all in, Also, another way to get your initial measurement for doing this is that you get on your phone, you'll get a thing called an all-in-one calculator. An all-in-one calculator will give you different shapes and whatever you want you can plug in. And all I did was I plugged in the diameter of this circle, which was 40 millimeters, because we have to cover this distance all the way around. The the circumference is 125.66 millimeters. So what am I going to do? Take my handy dandy ruler, measure out 126 millimeters, because I'll file to fit, and clean it all up and cut them out, and I think we're going to be good to go. That'll give us a real quick initial assessment, so we have less grinding down the road. Then we'll set the depth on where exactly we want it, set everything up, and then I'm going to tack it all in. That's another small step that we need to do. All right, let me get my mask on so we can so I can clean this up. I want to clean up the edges here also, so I can weld everything relatively easy. And yeah, let me just get this stuff squared away. As you saw, I just tapped down all of the spacers on the manifold because I want it equal, let me grab this, with this shoulder right here. And this is what they are. So all these spacers are now equal with the shoulder all the way around. What I want to do next is to make sure the depth for, like, here's the O-ring, put this in here. See, it's equal all the way around. The depth is pretty good. So when when the throttle bodies go down and pushes on the O-ring will seal up against the outer surface and shoulder of this portion. And this right here, the only thing is, it's preventing the O-ring from being sucked into the motor during vacuum. All right, now let me go get the welder. I'll weld this up and we will get everything set up and continue with our small bits and pieces to continue. What I'm doing here, you see this? This washer is setting the depth of that center section right here. This represents the external portion of this actual cup. And what I want to do here is squeeze everything together so they don't move. You have to make sure the washer is not contacting any of the external ridge right here because we were only setting the depth right there. So that's what I'm doing. I'm just setting the depth so it's going to be equal across. I mean, it doesn't really matter how deep it is, but just as long as you set it to the point where it's all going to be equal, you know, that's all you really care about. And that's what I was doing here. I was setting the depth of that inner ring, you know, the spacer ring, onto the throttle body. That's why I was pushing it down and tacking it on the sides. That's it. So what I gotta do now is I get just to lay the weld to her. It's pretty much it. Or lay the weld to this, transfer it over, lay the weld to that. But this thing is not going anywhere. And that's pretty much it. So let me get the rest of this stuff done. I think it's gonna work out. Here's the atrocious welds on my intake manifold. At least you're not going to see this. The big thing is it's all in there, it's flat. I had to cut this right over here in order to push it flat because it did bend up a little bit. It is what it is. The main thing is it fits flat all way. I mean, there's no movement or anything like that. Next thing is we have to go from here to there. This right here was our angle that we need, you know, that we had with the other intake manifold. Now, seeing how this is smaller, we're going to have to angle the pipes over to go into it. Just like a, you know, even just looks like the Porsche ones, you know. But what I did here is I put this piece of cardboard in. I marked the center line of this bore. I went over here. I said, okay, this is pretty much equidistant right here and where we kind of want it. I marked the center bore as right here on this. So that gave me the angle of what I'm going to cut the first pipe for. So I'm going to cut two pipes exactly the same, and they're not going to be very far because we can't have them very big with just the angles. So what will happen is I will measure down on this 1 inch. I'll cut a 10-degree angle, then cut it flat here so we have two of the same angles over here and over here to try and mate it up to this manifold. This is a long and involved process that's going to take a little while to do. But let me start doing this, and then we'll come back after I cut all the pipes. And no, well, I'll film it, of course, but I'll cut all the pipes, and then we'll figure out how we're going to set the angles, and then weld it all in. Oh, well, we're going to weld these in first, but at least we can make sure we can get the entire pipe around here, and then we can figure out angles and make sure we can get all the nuts off, and turn the distributor also. Small things, but it's all small. We're just going to slowly build up. That's it. It just takes a little time. looking at it from this angle, those ports are going to be right on at, you know, centering with that angle right here, go right onto the ports. So what am I going to do next? I am going to clean this up with a flap wheel. I am going to center the ports right here, because we can easily see them, as far over as possible for the angles. Like this. That's probably a better one to do, because I can sit there and look at it. Okay, this is exactly it. And then I'm going to tack it in, you know, a couple of places. And then I am going to figure out, okay, we're going to cut the angle to make sure this does not conflict with a nut on this stud. That's a big thing. What I have to do now is just clean up all this. Get the welder over here. We're going to, you know, just tack it in like this, you know, just weld a little bit, but just make sure you get the full angle over this way, because we're going to be cutting on the side right here for the angle going to turn this up to, what was it, the 37 degrees that the original intake manifold is. And then we'll do the ones right here, which is going to be a little bit easier because we can just make a small template and figure out exactly what it is. But all right, let me get my stuff back on so I can sand this all down. This is already done, just have to clean this up, and then I'm going to tack that in, and we're going to continue on so we can get this thing done and get the entire episode done. So we'll have an intake manifold. If you're curious, this is in inches, but I call it pitch, but whatever. But what it was if you're curious, the first cut for the angle was 1 inch, and this one works out to be a half. So, which is pretty logical on where it is. Just thought I'd let you know. Now I got to move that and cut those pipes. Same distance, you know, same, you know, 1.5 inches basically on the highest end, and make it work. That one's really hot. But hey, take a look. The welds aren't that bad for an amateur like me, you know. This is still warm. It's getting warm to the gloves. What I want to do is I'm going to take the other ones off. I'm going to set the exact position of the original manifold. And then we'll get on to fitting the, just fitting it together. That's pretty much it. Yeah, I'm going to run over there and do that now. That's pretty much right here is where we're going to have to set it. Best case scenarios. Hopefully those will cool down enough. Let me put this stuff back on. I even got a brand new marker to do this. Now we have to take the angle finder, which is, we have to go back 37 degrees from the bottom of this. So where does that actually end up? Well, roughly right around here. So what I'm going to do, I'm going to take this depth gauge, go down to there, so if I set the bottom right here and the top right here, I will connect the dots. I'm just going to take my cutter and cut straight up and see what I got. So yeah, it's about the only thing I can do, only thing I can think of. So yeah, let me just get that thing squared away, and I think it's going to be okay. Done. I mean, the initial part is pretty good. I smoothed it all out. I got a fairly straight shot into the combustion chamber. We got a whole lot of expensive TIG rod right here. Oh, use lubricant when you're doing aluminum, especially with a steel carbide bit, because what happens is it just sheds all the particles. It doesn't stick on it. Check out this. Here's the intake manifold. It's not that bad. If you take a look at all this. Pretty straightforward, goes right in. I mean, yeah, but I loaded the TIG rod all up on here for this very reason. The pipe went down there and I cut into the TIG material that way, just so it would get a nice a cleaner shot towards the actual intake port. Now we can put the O-rings in. Let's throw this on the head and set the throttle bodies up. Let's take a look and see how they look, and then we're going to end the episode. I think that's cool. It looks mean. Oh, wow. What do we have? You know what? We've solved an awful lot of problems in doing an EFI conversion, especially to a car that was never designed for an EFI system. What do we have? Well, we have the fuel rail. We have fuel injectors. We have throttle bodies, but we have a throttle position sensor. I mean, it's all right there. And I have room to move the distributor. It's pretty cool. I think we're trying to have the same type of aspect or same type of understanding of what the motor originally was. And what I'm trying to say is this is the original manifold. The original manifold, straight through design, no restriction whatsoever that going into the cylinder head from the intercooler. Well, when you open up the throttle bodies, same thing as that, no restriction. So I think we're good to go. I mean, same type of, same style or same air of it, but I think this is going to work out great. Two things. First thing is, the throttle bodies are further out than I would like them to be because I have a point right here where they're supposed to be right here. So it's about 1/2 inch to 3/4 of an inch out. I did not make the bracket to compress the throttle bodies onto the intake manifold. The reason is, I have some ideas and they might be doing double duty. But I got to continue with other stuff and then come back to it and see exactly how it is, because it has to go in there, no conflictions, whatever, and go right in there and compress these equally, plus do it, so you can get it off really quick. So other than that, next time we're going to be doing the turbocharger and the exhaust. I think that's going to be kind of neat. I think there'll be more people that are just thinking I'm a friggin' heretic, but I think it's friggin' fantastic. I mean, who else takes a goddamn jack handle and a bunch of scrap aluminum and builds an intake manifold for an R5? I mean, not very many, but it kind of worked out. I mean, that's what the most dangerous thing to having an aluminum weld is that you use it. So, I mean, I just think it's great. Yeah, I really like it. So thank you very much for showing up. Remember, you can do this. It's straightforward, just putting pieces together, and hopefully this will work. I think it will, but hopefully it'll work, and hopefully it'll work for you too. So I hope you have a great day, enjoy yourself, and thank you very much for showing up. We'll see you next time. Bye now.